This is the OCR 21st Century GCSE Chemistry paper, November 2020, and it's the Hayate paper. We're going to go through question 1. Layla does a titration to find out the concentration of some sodium hydroxide solution. She reacts hydrochloric acid with the sodium hydroxide solution. Layla says the titration uses a neutralisation reaction. Define a neutralisation reaction. So this is just asking to define what is a neutralisation reaction. So this is the reaction between an acid and an alkali. So obviously it produces salt and water. That's neutralisation. If you said that won't give you any more marks. The key bit that it's asking you here is the reaction between an acid and an alkali. Part B. This is Layla's incomplete method for the titration. Put the hydrochloric acid in a burette. Okay, so this is our burette. Put the sodium hydroxide solution in a flask. So we've got a flask here. Feel free to draw diagrams in the exam to help you understand what the text is saying. Add the hydrochloric acid to the sodium hydroxide solution. So we've got acid in here. We've got sodium hydroxide solution, so that's the alkali. So this is a neutralisation reaction happening. So it's been added from the burette. Stop adding the hydrochloric acid when the sodium hydroxide solution is neutralised. Okay. Layla needs to add another substance to the flasks so that she knows when to stop adding the hydrochloric acid. Which substance does Layla need to add, and what will she see? So Layla needs to add something that changes colour based on the pH, okay, and that is called an indicator. So if you just write indicator, that would give you the mark. So an indicator is a substance that changes colour based on whether it's in an alkali solution or in a acidic solution, okay. And what will she see? She will see a colour change, okay. So we need that because it will help us to identify when the acid has been when the alkali has been neutralised by the acid, or the other way around. So you'll see a colour change when neutralisation happens. Part II. Layla titrates the hydrochloric acid into a flask from a burette. She wants to make sure her final burette reading is as accurate as possible. Describe one thing Layla can do to make her reading as accurate as possible. So this is for 1 mark. There's a lot of different things we could have mentioned for this one, but obviously you need only one of them for the mark. So you could have said take a reading at eye level, so obviously to make your reading as accurate as possible. Take a reading from the bottom of the meniscus. So the meniscus is basically like a C-shaped surface of the water, so the bottom is here at the bottom of the C-shape. So you could have said take a reading from the bottom of the meniscus. You could have said make sure no air bubbles in the burette, or air in the burette, because that would affect your values. And you could have said add the sodium hydroxide drop by drop from here, from the burette. Any one of those would have given you the mark. So I'm just going to write take reading at eye level. Okay. Next part. Part CI. Layla's results for her rough titration are shown in table 1.1. Complete table 1.1 by calculating the volume for the rough titration. So thinking back to the diagram we had, the burette, obviously burette doesn't look like that, but it's just a rough diagram, and the conical flask. We've got initial reading, so it was probably somewhere here, 0.90 centimeters cubed, and then we've got a final burette reading of 25.8, so this is 0.9. So after the acid has been added, you got a final reading of 25.8. So to calculate your rough titration, the volume for your rough titration, you do the difference between the two, because that tells you how much volume you've added. Okay, so we just do 25.80 minus 0.90, and that difference is 24.9. 24.9. Could have put 0 there as well, it doesn't matter. II. Layla's repeat readings for her careful titrations are shown in table 1.2. So we've got first, second, third and fourth titrations, and they're the volumes here in centimeters cubed. Layla calculates that the mean titration volume is 24.60 centimeters cubed. Explain why Layla is correct. Okay, so obviously we know the mean is when you add all the values up and divide it by how many there are. So in this case we add all of these and divide it by 4. It seems like we have to do that, but actually once you do that you don't get this value. So you have to think what she might have done, and you have to look carefully at these values. Okay, what she has done is she's actually gotten rid of this value. Okay, and that is because this is 24.95. The rest are very close to each other. They're like very consistent. So we've got 24.65, 24.60, 24.55. So they're not very far away from each other. But 24.95, there's if you're looking at it accurately, it's got a much bigger difference than the other three. So for this question, you could just say for the first mark, you'd say Layla has removed 24.95, okay, from her mean calculation, or you could have said 24.95 is an outlier, because that's what an outlier is. It doesn't fit the trend or the pattern in your results. Yeah, so that's your first mark. For the second mark, it's asking you and a calculation in your answer. Use the information and a calculation in your answer to say why she's correct. For your second mark, add 24.55, 24.65 and 24.60. So you add all of these three values, you're calculating the mean of those three values, and you're dividing it by 3, not 4, because you remove that value, and that should give you 24.6, okay, 24.60. And then the last part for this question, calculate the mass of acid in 1 centimeter cubed of hydrochloric acid. Use the formula mean titration volume is equal to 0.0908 divided by mass of acid in 1 centimeter cubed of hydrochloric acid. Give your answer to 2 significant figures. Okay, this is a very important part. Try to read the whole question carefully and follow the instructions, because this by itself gives you an extra mark if you write your answers to 2 significant figures. So first thing we need to do here is rearrange this equation, because we need to calculate the mass of acid. We need to calculate this part. Okay, we need to calculate the mass of acid. So we rearrange the equation, and that gives us the mass of acid in 1 centimeter cubed of hydrochloric acid is equal to 0.0908 divided by this mean titer volume. Okay, we just rearrange it. Titer volume. And obviously our mean titer volume we get from the other part from this question. The mean titer volume is 24.60. So we divide it by 24.60, and then if you type that into the calculator, you should get 0.00369, and you can just put dots there to show the number carries on, and obviously it's mass, so it's in grams. So now what you need to do is write your answer to 2 significant figures. So your first significant figure is the first number that you see, which in here is 3, because these are all zeros, and then this is our second significant figure, 6. But because there's a 9 after it, this 6 goes up to a 7. Okay, we round it up to a 7. So our final answer is 0.0037.